promise.
No, I'm just, it was a stretch.
Okay. So, what do we know about e to the x and natural log of x? Not opposites, they are inverses. Opposites and inverses are totally different. Okay? Opposites would be like 1 and -1. Inverses are 2 and 1/2, so just be careful. Okay, so first of all, if I were to talk to you about the graph of e to the x, we're going to sketch that first, okay, because we can approximate values. I'm going to make a sketch of a graph right here, like this, okay? And if I pick points, let's pick the easiest one, let's plug in 0. What's e to the 0?
1.
It is 1. So we'll say that 1 is right here. What's the approximate value of E? Okay, 2.7. That's enough, right? 2.7, something, something, something. Don't care. I can figure out where 2.7 is. So if I plug 1 in for X, that means I'm going to be at approximately 2.7. So maybe right here. Those of you with a calculator, if I plug in -1, E to the -1 is really 1 over 2.7. What is the approximate value of that? Yeah, as I said, those of you with a calculator.
Oh,
Yeah, okay. So about 0.4, right? If we were to round 0.37, 0.4. So that means if I go to -1, I'm at about 0.4. So we have 3 points. We can kind of figure out what the graph is doing. Goes like this, right? This is y is equal to e to the x. So this is my graph right here. So here's my question. If I were to ask you, given this graph, what is the limit as x is approaching positive infinity? What's the graph doing? Yeah, it's going to positive infinity. The limit as x is approaching negative infinity. Exactly. What is 0 for y equals e to the x? It is. It's a horizontal asymptote, okay? So that's why these characteristics are important. Now, instead of memorizing them, if you can just sketch the graph quick, you can see what's happening. Okay, so if you know that e to the x and natural log of x are inverses of each other, we already talked about this, how can I find the important points for the natural log of x? Because, yeah, I can't say, oh, what's the natural log of 1? What's in it? Well, that one you should know. Natural log of 2, natural log of 3. I don't know. I need a calculator. But if I said I know that they're inverses, if this is the point 0, 1, then 1, 0 is going to be significant. If this is the point 1, 2.7, then 2.71 is going to be significant. If this is -1, approximately 0.4, then 0.4, -1 is important. Agree?
yes.
Okay, because now my graph goes like this. And this is y is equal to the natural log of x. So if I ask you, what is the limit as x is approaching positive infinity for the natural log of x, what are you going to give me? As x is approaching positive infinity. Yeah, the graph is, it looks like it's not flattening out, but it's going to take a while to rise. Yeah. So in this case, I can't ask you what's the limit as x approaches negative infinity, because we had a horizontal asymptote for e to the x, so that means its inverse has a vertical asymptote, more specifically at 0. So that's why this says, what is the limit as x is approaching 0 from the right, and it's negative infinity. Okay? All right. So let's answer these last two problems, okay, using conceptually what's going on with the graph. So I could tell you right now, if I plug in negative infinity, this is going to get it all jacked up, right? Most likely it's going to be either infinity over infinity, something indeterminate, or something I can't add or subtract. Do you agree? It's based on pattern, what we've done. So if I try to simplify this, I want to simplify these negative exponents first to see what's happening. I have the limit as x is approaching negative infinity of e to the x plus 1 over e to the x. I'm just simplifying these negative exponents. Okay, this gives me a complex fraction. And we know we're not allowed to deal with those. We got to fix them first before we can do anything. So how do I get rid of that complex fraction? Okay, multiply by the least common denominator. Nice guess. What is the least common denominator? It is e to the x. Okay, before we do this, I just have a quick question. When your base is the same and you're multiplying, what do you do to your exponents? Just checking. You add them. Okay. So I have e to the x here over e to the x here. So when I multiply here, my bases are the same. You just told me you add your exponents. So we have the limit as x is approaching negative infinity. What's e to the x times e to the x? E to the 2x. What is e to the x times 1 over e to the x? Nice. Plus 1 over, okay, what about the bottom? What do I get here? E to the 2x minus 1. Agree? Okay, so complex fraction is gone. So this is what I want to ask you. You have the limit as x is approaching negative infinity of e to the 2x. Let's look at e to the x. The limit as x is approaching negative infinity of e to the x, we know goes where? Where's it going? As x is approaching negative infinity. Look at the green. It's going to 0. Okay, so e to the x versus e to the 2x. Is that going to change what my graph looks like in terms of end behavior? What it's really going to do graphically is instead of it gradually going up like this, it's just going to shoot up quicker. Okay, but it doesn't change end behavior, does it? So then if I evaluate the limit as x is approaching negative infinity of e to the 2x, what is it? It's still 0. And then the limit as x approaches negative infinity of 1 is I said it before, the limit as x approaches any value of a constant is a, so it's that constant. So then what's the answer? It's just 1. So if this was a 5, what would this be? Yeah, it doesn't matter. Limit as x approaches negative infinity of e to the 2x, you guys told me is 0, so what's this? Minus 1. Okay, so then what's my answer? Negative 1. Okay, so not as hard if you know what the end behavior is, right? Maybe? Go over what part? The who? Okay, so e to the 2x, the only thing that's going to change is how fast this graph shoots up. The end behavior is not going to change. The right side is still going to go to positive infinity and the left side is still going to go to 0. Okay, so let's take a look at here. This is our last problem. We have the limit. This is essentially the limit as x is approaching positive infinity of the natural log of 1/3 x squared. Okay, here's my question. We did it already with e to the 2x. If I said to you the limit as x is approaching positive infinity of the natural log of x, end behavior, that's fine, right? You can get that. What's going to happen if I square the x? Instead of gradually going like this, what do you think it's going to do? It's going to shoot, right? It's going to be flatter. Like this one is just kind of gradually going up. It is going to kind of shoot straight out. What if you divide it by 3? Is that going to affect end behavior? No. It might affect, actually, it is either a stretch or compression, vertically, horizontally, however you look at it. But again, end behavior, does that change? Not at all. So when I'm looking at this, all I'm doing is focusing on the end behavior of the natural log graph. There's some other stuff happening to it. It's either going to be flatter, more compressed, whatever. But what is the end behavior as x is approaching positive infinity? Where's y going to eventually go? It's going to take longer, but where's it going to go? It's going to go to infinity. Okay, it's just going to take longer because it shoots out so fast. It's just going to take longer to rise. Does everyone understand? Okay, so the answer is just infinity. Okay, does anyone have any questions?